So when we focus on these macronutrients, carbohydrates, protein, fat, they break down into three groups. I've put some examples up here so that you could see what these three groups are. And in here then you can see that, for protein we're talking about animal meat, okay? Basically fish, poultry, beef, lamb, any of that, wild game. Now you can see sometimes these macronutrients don't always come by themselves, right? They're mixed together. Like you can see in the steak, the marbling is fat there. So fat and protein together in a steak. But if you were to eat chicken, like a boneless, skinless chicken breast, pretty low percentage of fat. It's mostly just protein. Okay? If you were going to eat egg whites, you could separate the egg whites from the yolk, and you're separating the fat from the protein part of it. When we talk about fats, we're talking about oils, butters, things like that. And for the most part, for our discussion, we're thinking of that mostly as things that would be, we use to cook, but we're going to try to, recommend that you're eating leaner proteins to begin with. Though you'd be surprised that if you have less carbohydrate, your body tolerates more fat without raising your cholesterol, and there's very good reasons for that, and we'll hopefully get to that. Carbohydrates get kind of complicated. A piece of candy is carbohydrate, right? Made out of sugar, or what we would commonly refer to as sugars, is carbohydrates. But also a carrot or an onion, right? And there's other things in there, like in the fiber and things like this that we're talking about, water. Like a cucumber is probably 90% water and only 10%, carbohydrate. And some of that is a little bit of fiber in there, so especially if you eat the peel, right? But all of these actually, our body treats the same as carbohydrates, and we're going to see how this is going to critically affect our weight and blood sugar and cholesterol. Because you have to remember this, when you eat a food, it's got to be broken down into the smallest particle it can be broken into, so that it can get through the intestinal wall, right? And we have a picture. This is actually a picture of a lab cross-section for a rat. But the human structure is very similar. And what I wanted you to gain is that this is how microscopic the food is going to be. So it's not, when we think about eating, we think about chicken and beef and turkey and sandwiches and casseroles. But when we think about what's in our bloodstream, we have to break it down to the macronutrients, protein, fat, carbohydrates. That's what's getting in that form. And if you've heard reference to calories, calories is the energy output of those foods that we're eating. And I like to equate the different type of calories with a different kind of the energy outputs of the different macronutrients. And so if we were to think about the basic reason why we're eating these macronutrients, it really boils down to energy. We're eating these, protein, fat, and sugar, mainly for energy, but also to repair our body, right? And there's a lot of other micronutrients, all the vitamins and things like that play a big role in that as well. But for us, talking about metabolism, we're going to focus on this aspect of these foods. And so if we were to think in terms of energy, like heat given off by a fire, when we think about fats, for example, fats are going to give us long, slow-burning energy, just like a log on a fire, okay? And so when we eat fats, they actually give us greater satiation, or reduce our appetite for longer, or give us more energy without getting hungry, because they're higher in calorie. They're packed with energy, but the energy is slow burning. It comes off very slowly, okay? Because it's got to be broken down first so it can be used. Now, when you think about protein, I like to think of those as like a fire made of twigs. It's going to burn longer than maybe one made of just leaves or paper, but not as long as a log, okay? And so it's maybe not as long lasting of an energy source, but longer than maybe carbohydrates. And when I think about carbohydrates as energy, I like to think of them as, high powered, high fuel, octane, starchy foods are meant to be, I call them rocket fuel sometimes, if you're eating, something that's very starchy, like a baked potato, let's say, or something, like bread or pasta especially. So these are high-powered fuels, but the problem with high-powered fuels is they burn up right away. They don't have that long-lasting effect. They don't keep you full for a long period of time. It's like rice and pasta and bread. If that's all you ate, you're going to be hungrier sooner. That energy is going to dissipate, and your body's going to try to conserve that energy, right? So if you get this big burst of energy, what your body wants to do is take that extra energy and store it as fat. And with this, I kind of equate that if you were to burn leaves, that's like how your body burns carbohydrates. Well, if you burn leaves, you also get a lot of smoke too, right? And carbohydrates can be somewhat irritating to your system depending on what carbohydrates you choose, okay? And so again, this is kind of a model I made so that we can see how these things break down. And basically you're going to ingest food, break it down in your mouth and your stomach into those three macronutrients: the protein, the fat, the carbohydrates, or sugars, okay? And then those are going to get absorbed into your body, and then there's kind of a hierarchy of how these get used, okay? Your body is going to prioritize. It's very efficient in everything that it does. It's not going to waste energy doing things. It's conservative by nature when it comes to energy. So it's not going to shift things around right away when you eat them. That'll come a little bit later when it sees how your body responds to what you ate. So if you're eating fat, your body's not going to change fat into sugar immediately and burn it as energy, unless you have a need, all right? What it's going to do is take that fat and it's going to repair things that are made of fat, like your nerves, all your cell walls. Think about all the skin cells that you lose in a day, and so you're losing cells constantly. You constantly have to replace them. Well, all the walls to all the cells are made of fats, and that has to be replaced, okay? And then your nerves are protected by fats, and that has to be replenished. And also all your hormones, testosterone, progesterone, estrogen, that's all made from fats. So essentially fats. So it's going to go through those things and use those things appropriately, and then it's going to store whatever excess fat is not being used, okay? And fat is going to be stored as fat. I mean, that's what it is. Now, protein, when you take in protein, it's going to be used to repair muscle. Every time you exercise and work out, you break down muscle tissue, and those proteins have to be restored. And so you're going to do that. You're going to repair your muscle. You're going to make more muscle, hopefully, if you're working out. A lot of enzymes are made of protein, and those will have to be made to do the different jobs around your body. And then your body, it can store the excess protein as fat, but it would have to be converted to sugar and then fat. But also, the thing with protein, sometimes you'll just urinate out extra protein. You won't actually store it so much. Sometimes you can lose a little in your urine. And when we talk about sugar, something different happens. It's something that is profound to our talk, because this one different thing that happens changes a lot about how we lose weight, how we gain weight, what happens with our cholesterol, things like that. And what happens is when blood sugar is tightly regulated in the body, and those sugars, if they reach a certain threshold, will cause insulin to be released. And then insulin is a hormone that is going to tell every cell in your body a certain message. And usually insulin tells sugar to get out of the bloodstream and into the cells. And if the cells cannot process it because you have enough energy, they're going to send it to fat storage, okay? And that's a profound message, because this hormone is dictating when you burn fat and when you store fat. And it's being controlled by when you eat carbohydrates and when you don't eat carbohydrates. So this is really a big deal for what we're going to talk about. And I'll spend